This video demonstrates how to create a wind turbine capacity calculator in Excel. It establishes several constant values and then calculates the capacity of wind turbines in watts, kilowatts, and megawatts. The formula used to calculate a wind turbine's capacity in watts is 0.5 times rho times A times V to the third power times C subscript P. Note that 0.5 is a value that is kept constant for this lab. It is a value derived from the equation used to calculate kinetic energy. Rho is 1.225. This value is kept constant for this lab. This is air's density in kilograms per cubic meter at 15 degrees Celsius. A is the circular area swept by a turbine's blades in square meters. V3 is the velocity of the wind in meters per second cubed. C subscript P is 0.4. This value is kept constant for this lab. It is the power coefficient, or efficiency, of the turbine. Wind turbines have a maximum power coefficient, known as the Betz limit, of 59.3%. In order to use the formula, we must first solve for A. Recall that A is the circular area swept by a turbine's blades in square meters. Since the area is a circle, we use the formula pi r squared to solve for A. Note that pi is 3.14 and r is the radius of a turbine's swept area squared. Row 1 of your wind turbine capacity calculator must have the following 8 headers. Wind turbine name. Enter rotor diameter in meters. Rotor radius in meters. Circular area swept by turbine's blades in meters squared. Enter wind velocity in meters per second. Capacity in watts. Capacity in kilowatts. And capacity in megawatts. Highlight cells B1 and E1 by clicking cell B1, holding down the Control key, and clicking cell E1. In Excel's Home tab, within the Font area, click the Fill Color icon. Notice that this highlights the background of both cells with a color, thereby making them stand out. The formula we use for calculating the capacity of a wind turbine contains several constant values. It also requires us to raise the radius of the area swept by the turbine's blades to the second power, and raise the wind's velocity to the third power. We accomplish this in Excel by using the caret symbol, which is also called a circumflex, and then typing the power value. On most keyboards, the caret symbol is located on the number 6 key. Format columns D, F, G, and H to have no decimal place and a comma 1000 separator. Accomplish this by clicking on column D, then holding down the Control key, then clicking on columns F, G, and H. Notice that this highlights the columns. Right-click on any highlighted column, select Format Cells, select the Number tab, select the Number category, reduce the decimal places to 0, place a check in the box named Use 1000 Separator, comma, and click the OK button. Notice that cell B2 already has a value in it, as does cell E2, thereby allowing us to see how the calculator functions as it calculates the capacity of a turbine with a rotor diameter of 84 meters located in a place with winds blowing on average 9 meters per second. In cell C2, type an equal sign. Then click on cell B2, then type a /, then type G2, and then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for rows 3 through 6 by clicking and dragging the small green square in cell C2 all the way to cell C6. Notice that since there are currently no values in cells B3 through B6, the formula yields 0 for cells C3 through C6. In cell D2, type an equal sign, then type capital P, I, and then an open and closed parentheses. Then type an asterisk, then click on cell C2, then type a caret, then type 2, and then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for rows 3 through 6 by clicking and dragging the small green square in cell D2 all the way to cell D6. Notice that since there are currently zeros in cells C3 through C6, the formula yields 0 for cells D3 through D6. In cell F2, type an equal sign, then type 0.5, then type an asterisk, then type 1.225, then type an asterisk, then click on cell D2, then type an asterisk, then click on cell E2, then type a caret, then type 3, then type an asterisk, then type 0.4, and then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for rows 3 through 6 by clicking and dragging the small green square in cell F2 all the way to cell F6. Notice that since there are currently zeros in several cells, the formula yields 0 for cells F3 through F6. In cell G2, type an equal sign, then click on cell F2, then type a /, then type 1000, and then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for rows 3 through 6 by clicking and dragging the small green square in cell G2 all the way to cell G6. Notice that since there are currently zeros in cells F3 through F6, the formula yields 0 for cells G3 through G6. In cell H2, type an equal sign, then click on cell G2, then type a /, then type 1000, and then hit the Enter button on your keyboard. Notice that Excel calculates the answer to the formula, and also notice that Excel's formula bar displays the formula. Duplicate this formula for rows 3 through 6 by clicking and dragging the small green square in cell H2 all the way to cell H6. Notice that since there are currently zeros in cells G3 through G6, the formula yields 0 for cells H3 through H6. Use this calculator to determine the capacity of other wind turbines after obtaining their rotor diameters and the average wind speeds at their locations.